Yeah, okay, I'll do so. I'll remind you about it.
Thank you very much. And let's see. Um, I have some unfortunate news. This material in week 2 is notorious. Notoriously difficult. It's not that they went out of their way to find hard problems. No, just it's one of those topics that people, just usually have a difficult time with. So I wouldn't be surprised at all if it gave you some issues. Not so much with inequalities, but linear equations. It starts off easy and then gets hard in a hurry. So if there's something we're not understanding, please bring it to my attention. Inequalities. Like the name suggests, it's mathematical. Inequalities are mathematical statements, but they involve the other symbols that aren't the equal symbol. I mean, all you ever have is equals, not equals, less than or equal, greater than or equal. And this one we're not using. We're just going to talk about these when we talk about inequalities. In fact, the homework assignment really only focuses on these, which is fine. But these 6 symbols are all of the equivalence relations that are possible to describe. And I guess I can say that these 2, it doesn't talk about. We sort of know what not equals would mean. It just means different from. In the same way that you know exactly what equals would mean, it's that they're one and the same. All right, now when you read a book or when you read something on a sheet of paper, you read from left to right. And you can read one of these inequality symbols in the same way. So as I'm looking at, let's say, this statement in blue, I know they're talking about A. It relates to B in some manner, and as I read from left to right, I can interpret this symbol that, well, it's got the big side here, the big opening, next to the B, and the little tiny side that comes down to a point next to the A. It's trying to indicate to us that the value A is smaller than the value B. So A is less than B. And a typical adjective that is inserted in here is the word strictly. A is strictly less than B. Under no circumstances could A ever be the same as B. It's strictly less than B. Here's your, no, not that. Here's your number line. There's B, and A has got to be down here with this clear space between them. A is strictly less than B. However, if they use the less than symbol and it's got this extra line, then that's because this part of it here would look like an equal symbol. And if you wrote all of this together, you'd be saying that A is less than or equal to B. It's not strict in the sense that that for sure both of them prevent the scenario where A got past B. Right? For both of them, A is not over here. However, for this one, for A is less than or equal to B, you could have them be the same quantity. And it would still be true. If A and B were the same number, and I wrote this down, it would be a true statement. So it just means A is less than B or A is equal to B. And of course, the other, when the symbol faces this direction, it's greater than, or it's greater than or equal to. Even though in math, even though in English we read from left to right, in math, that's more rare, except for when I explained how we read this symbol. You can interpret it the other direction. So on the one hand, this would say B is greater than or equal to A. I promise you, though, that this is a cumbersome way to talk. It's much preferred. I prefer, and hopefully you would prefer as well, to restate a greater than or equal to well, let me use some numbers as an example. So this would be 3, and this would be x. Then what it says is 3 is greater than or equal to your number, to this value of x. But that's a pain in the behind. It would be much easier to rewrite it with the variable on the left, so that way first I'm talking to you about this quantity x, whatever it may be, and then I can say x is less than or equal to 3. Notice that in each case, the pointy side points to the x. So they mean the same thing. X is less than or equal to 3. And this is the one we like, and this is the one that stinks. A word about sets. Mathematicians get all worked up about sets. It's a big deal in math. What is a set? What does it mean? And there's whole branches of mathematics, set theory, completely devoted to the idea of sets. For you and I here, this word sets has no formal definition for us. To us, it's just a collection. Our notation is strict, though. If I have just a list of numbers, like 2, 6, and 13, then this is a set. It has 3 numbers in it. You can see all 3 of the numbers that I have included in this set. It only contains these numbers. It's a collection. If I had to talk about, this was when it was finite. I only had a finite number of things to go in my set, so I just list them out, and that's how you do it. And you use these curly braces. They're called curly braces. In most cases, I think actually in every case, on the homework throughout the semester, if they're talking about a set and they want you to give them the set, like the set of solutions, they would have the curly braces already put there. And that's if it's finite. If it's infinite, then they're talking about, if it's infinite, then it can be equated to some segment of the real number line. It must be a segment of the number line. So if my number line is here, and I'm talking about the set of numbers from 0 to 1, and I wanted to include the number 0 in my collection, but I did not want to include the number 1 in my collection. And I wanted every single number inside of here, then I would write my set as the interval from 0 to 1. This is a set. It's more common to call it an interval, but it is a set. It's a segment of the number line. And naturally, there's an infinite amount of numbers between 0 and 1, and then you toss in 0 itself, it's still infinite. And so we have finite sets, we have infinite sets. There's other ways to write infinite sets that we'll do later in the course, but this is it for now. Okay. Let's do an example then. So, yeah, what's up?
So for infinite set, the braces are like square and round. Doesn't matter.
Oh, yes. Yes, because I said for this set in blue here, or for this blue writing down here,
yeah,
we said that this was going to be all of the numbers between 0 and 1, but it would include 0. So this would be the collection that was bigger than or equal to 0, but less than 1.
Okay.
Okay?
Mm-hmm.
Okay, great question.
Thank you.
This is an equation. It has an equal symbol. So it's an equation. Let us solve it. We have our 4 steps that can solve any equation of this type. You distribute, you combine like terms, you do your additive inverse, you do your multiplicative inverse. Okay, well, distribution and combine like terms, nothing to do there. All we need to work on is additive inverses and multiplicative inverses. Clearly, we would want to solve for the k. And the term that has the k has got something being added to it. So I need the additive inverse of 2, which is negative 2. And I have chosen that additive inverse of 2 because now these terms would add to 0. Plus 2 and negative 2 would add up to 0. And so I don't have them. So then the only term left on the left-hand side would be the 3k. On the right side, you get whatever you get. So rewriting it, we have 3k equals to minus 21. I'm done with additive inverses, and I know that I'm done with additive inverses because look, nothing else is being added here. No more addition. Time to move on to multiplicative inverses. I would now want to multiply on both sides by the multiplicative inverse of 3. Well, another name for multiplicative inverse is reciprocal. So I would be multiplying on both sides by 1/3. Well, that's the same thing as saying I'm going to divide by 3. means the same thing. So divide on both sides by 3, and then the equation is solved. And we have that k is minus 21. So our solution set is finite. It would just consist of the number minus 21. Minus 21 is the only such, yeah, sorry. Wasn't paying attention. Minus 7. Minus 7 is the only point on the number line that if I took it and put it right here for k, then the equation would be true. 3 times minus 7 plus 2 really is negative 19. This is my solution set. Well, now I have the less than symbol. Instead of the equals. Everything else the same. And for all intents and purposes, you can do everything the same with only one caveat. We won't have that problem here, but we will have the problem eventually. We won't address it until we need to. For now, just you can do all of the same algebraic steps as if this was an equal symbol and not an inequality for now. So I would need my additive inverse of 2. It yields for me that 3k is less than a minus 21. I divide by 3 on both sides and get that k is less than minus 7. Translate this statement to a picture, a graph. Draw a little number line, put a minus 7. Then the region of this number line that has the numbers that are less than minus 7 is this region over here. I would not include the minus 7 because this is strictly less than negative 7. If it is strictly less than negative 7, then it does not belong in our solution set. The number negative 7, if I put negative 7 right there for k, then this would not be true. Because minus 19 is not less than minus 19. So negative 7 itself cannot belong to the collection. And then way over here at the end of the line, you have minus infinity. You can't include minus infinity either because, hey, you're never going to reach it. Okay, well, now my picture looks like what my answer should look like for the solution set. The solution set would be any number in this interval from minus infinity to minus 7. This is my solution set.
I wanted to ask
Yeah.
a question. Like on the solution set, do we put parentheses on both sides, or do we put the square one where there is infinity and parentheses on the other one?
So let's spend a little more time with that idea. And we'll just cover several cases. So if I'm talking about the interval from 0 to 1, then this thing does not include 0 or 1. It does not include 0, and it does not include 1. If I am talking about this interval that has the square bracket on the 0, this is the same interval as the interval from 0 to 1 together with the single point 0. This is analogous to a plus sign. It's the union. It's you take this interval that didn't have 0 and it didn't have 1, and you glue a 0 onto it. And you would get this. It does include 0, but it does not include 1. It does include 0, but not 1. If I had brackets on both of them, then this would be the open interval. It's called an open interval. This is the open interval from 0 to 1. This one's half closed. And this one's the closed interval. And it's the same thing as the open interval plus the finite collection of points, 0 and 1. Which means it includes both 0 and 1. And of course, you could have it be half closed on the other side. And you would just glue onto it the point 1. And you would still call it half closed. Okay, so since we had a strictly less than symbol here, it was strictly less than, so I must use the parentheses because the bracket would indicate that that minus 7 was included. In other words, if the problem was 3k plus 2 less than or equal to minus 19, then we would get that k is less than or equal to -7, and our picture would have a bracket. We'd be talking about these numbers, and the solution set would be from -infinity up to -7, but we would include the -7, but can't include the infinity. While I'm here, this object is not the answer. If you type that in, it'll count it wrong. It's a true statement, but it's not the solution set. They're going to want from you the solution set. It's this interval from -infinity to -7. They mean the same thing, but they're different objects. All right, that was number 1 from the homework. Here's another one. (2x minus 4) is greater than or equal to -8x. All right, let's play with this one for a minute. So I know I need to do, there's no distribution, there's no like terms to combine. Remember, combining like terms just looks on either side. Those don't combine, and this doesn't have anything to combine with, so there are no like terms to combine. Now I need to do some additive inverses, multiplicative inverses. Let me first have you do the additive inverse of, I want to add 4 on both sides, and add 8x on both sides. Adding 4 on both sides makes this part add up to 0. Adding 8x on both sides makes this part add up to 0. And then you can readily see what the resulting statement would be. The 8x and the 2x is 10x, and it would be greater than or equal to 4. Additive inverses are done because there's no more addition. So I would move on to multiplicative inverses. I should divide both sides by 10. I must divide by 10 because then 10 over 10 is 1. It says 1 times x. Multiplicative identity says that 1 times x is just x. So x must be bigger than or equal to 4 over 10. However, 4 over 10 is 2 times 2 over 2 times 5. And by the property of, or by the definition of multiplication of two fractions, that is 1 times 2/5. So we get that x is bigger than 2/5. It would then correspond to the, well, I would then draw a picture. I would want to draw a picture because they're going to ask you for a picture. There's my number line. There's 2/5. It's the numbers that are bigger than 2/5 because x is bigger than 2/5, or it's equal to 2/5. So I have to throw 2/5 in with the bracket, and it goes off all the way to infinity. So then my solution set is the interval from 2/5 out to infinity. This is my solution set. Now that wasn't the only way to attack this problem. The distinguishing feature of what I did here was very opaque. I added the 8x. I added the 8x on both sides. What if instead of doing that, you had said, well, I'm going to take this 2x and move it to the other side? That would be fine. Let's investigate that. So it was 2x minus 4 is bigger than or equal to minus 8x. So instead of adding the 8x to both sides, we're going to subtract the 2x. Now, if you know what's about to happen, don't say anything. So I'm going to subtract the 2x on both sides. Then over here, that adds up to 0. I can see what I'm left with. It would say minus 4 bigger than or equal to minus 10x. And then you would divide by the minus 10 on both sides. And you would have that 4 over 10. Because the negatives cancel, you'd have that 4 over 10 bigger than or equal to x. But this is cumbersome to read because the variable is on the right. So put it on the left and make the symbol point the same direction. And then 4/10 was really 2/5. Then you can draw your picture. And here's your 2/5. And it's telling me that it's these numbers less than 2/5 with the bracket out to the minus infinity. But wait, this is not correct. This is different than what we got over here. Over here, it pointed out towards positive infinity. And over here, it's pointing towards negative infinity. Such an example illustrates that one caveat that you have to pay attention to when you're dealing with inequalities. The mistake is right here. And it has to do with multiplying on both sides by a negative number. For me to divide by negative 10 is the same thing as saying I'm going to multiply on both sides by negative 1/10. There's nothing wrong with doing that, except for if you do that, the inequality has to point the other direction. Why, you would ask? This is why. Over here, I did it. I solved the problem. I never had to divide by a negative. I never had to multiply by a negative. Now we would all agree that this is the right answer right here on the screen. But when I didn't pay attention to this notion of having to flip the inequality when I multiply or divide by a negative, the answer came out flipped the other way. So to fix that flipping, of how it's going to flip it the other way if you don't flip the inequality, well, flipping the inequality is exactly what happened. So if I flip the inequality, then the ultimate effect is that the graph changes to point the other way. That's just what it does. So here it was a greater than or equal. Now it's a less than or equal. And so the pointy side points towards the number, and it says x is bigger than or equal to 2/5. So there's my number line, there's 2/5, and x is bigger than or equal to 2/5, so it's these numbers, and I have to include the 2/5, so my solution set is from 2/5 off to infinity. Questions so far?
I'm still confused at the two examples, like the first one where we didn't flip, yeah. Because there we eliminated the 4 and remained with 2x. And there we eliminated 8x.
Uh-huh.
That
happened
then
here,
we added,
here.
yeah. And then
Okay.
there we had 10x. So which method is right? Because sometimes,
They're both right.
oh, and how do you know now that you flip? Because this is where I get the confusion on this section of, yeah.
Okay, so watch this. Minus 2x bigger than or equal to 4. Okay? On the one on the left, I'm going to avoid multiplying or dividing by a negative. But on the one over here, I will flip the inequality if I multiply or divide by a negative. Okay?
Okay.
Okay. So on the one on the left, where I'm going to avoid having to multiply or divide by a negative, then, well, it's got a negative here. So let me just add 2x to both sides. And it'll make that term with the x, it'll make it into positive. So it would say that 0 is bigger than or equal to 4 plus 2x. The square braces are right above your enter key next to the P on the keyboard. Okay, this thing is almost solved. We got to use some additive inverses now. So subtract 4 on both sides, then minus 4 is bigger than or equal to 2x. For the other side, where I'm just going to, if I want to multiply or divide by negative, I'm going to flip the inequality. Then that's pretty much the first thing for me to do, is divide by a -2, then on the left side it just says x, but I'll make the inequality point the other way. Up here it pointed to the right, now it's pointing to the left. So x is less than or equal to a 4 divided by -2, which is just -2. Back over here, if I continue and divide by 2, it says that -2 is bigger than or equal to x. This means the same thing as x is less than or equal to -2, because look, the inequality points to x in both cases. And look at how we got the same thing. X is less than or equal to 2 in either case. What can you conclude now? Well, since in the version on the left, I did not flip the inequality, I simply avoided at all costs. I went out of my way to avoid multiplying or dividing by a negative. And on the one on the right, if I did want to do that, all I did was flip the inequality. Then this shows you that if you need to multiply or divide by a negative, you have to flip the inequality, or it will be wrong. Does that make sense, Rosalando?
Yes, it does. Thank you.
So let's do one more and then we'll go on break. Number 3 from my homework is a minus 2 times the quantity a minus 12 less than or equal to 3a. Well, here we'll have to use all 4 steps. I'll have to distribute. I'll have to combine like terms. Additive inverse, multiplicative inverse. When I distribute, the number to distribute inside is -2. Because this is really saying a plus this other stuff. It's a plus this term. So the number that distributes in is -2. You would get a minus 2a plus 24 less than or equal 3a. Has to be plus 24 because -2 times -12 is a multiplication of 2 negatives. Now we can combine like terms. These 2 terms are alike. They both have the same variable, and that variable has the same exponent. So they combine. A minus 2a, that's minus a. Minus a plus 24 is less than or equal to 3a. Then I can add a on both sides. Adding a on both sides, well, gives you 3a plus a, that's 4a. Divide by 4 on both sides, we have that 6 is less than or equal to a. That's unpleasant to read, so a is bigger than or equal to 6. And the pointy side still points towards 6 in either case. My number line looks like this. There's 6, and we're talking about all those numbers that are bigger than or equal to 6, so it's these over here, off to infinity, and it must include 6 because it's greater than or equal. And that would correspond to the solution set 6 to infinity, where 6 is included. Questions before break?
Nope.
Very good. So let's do 10 minutes. And I will see you at about 7:11. Okay, welcome back. Let's see here. Okay, that's everything to do with inequalities. I am asking a question on the attendance, and you have 10 minutes to answer it. It's not punitive if you don't answer it, but if you don't answer it, then it will look to the registrar like you weren't paying attention.
I'm checking on my attendance. I can't see the question. Unable to retrieve your information. Please go back to previous screen.
I don't know. Another student will have to help us out.
Where do I go to get the question?
I don't know. You go to the attendance app, I think.
Yeah, that's where I am.
Okay.
If you refresh and then click on mobile attendance again, and then go to attendance, click on attendance. It should say respond to question, and then you just have to click answer.
Okay. Oh, thank you.
Yeah.
Excellent. All right. Now it's time for linear equations. These would be equations whose graph is a line. There are plenty of other equations whose graphs don't make a line. And for now, the only ones we're interested are the ones that make a line. All right. And let's start with some ideas. So a long time ago, a mathematician named René Descartes, French mathematician, 1600s, visualized a flat plane. Well, he just said, let me think about this hypothetical flat surface that extended in every direction to infinity. And let me embed in that plane two number lines at right angles such that they both crossed at 0. Not a particularly difficult idea, but was powerfully revolutionary for the times. and it has his name as an honor. This gives rise to the Cartesian coordinate system. It is simply a scheme to give an address to any particular point on this hypothetical flat surface, such that if on one of the number lines you had some number and over here you had a number, then you could extend lines parallel to the axes, and then the place where they crossed would have an address now known as A, comma, B, an ordered pair. It's called an ordered pair because it has to go in a particular order. The number A would be called a coordinate, and B is also a coordinate. A is the x-coordinate, and B is the y-coordinate. Because the number B is on the y-axis, and its appearance in the ordered pair comes second, because ordered pairs always go like x, comma, y, in this order and no other order. And that's the Cartesian coordinate system. It's useful for an unbelievably high number of things. Okay, so let's talk about our first linear equation. You cannot get a line simpler than this one. I mean, I guess maybe if I said something like y was just 1, but we'll come back to that here in a minute. This is the guy to study. This is the guy to study. It is an equation, first and foremost. It's just algebra. It's just some equation. But there is a corresponding geometry underlying this equation. We know already that ordered pairs look like x comma y. And for this equation here, it's telling us that x and y are the same number. That's what this equation is saying. This one says x and y are the same number. So I can start to list off some points that would have to be on this line. Like the point 1, 1, or the point 2, 2, or -5 comma -5. Y must be equal to x. And since the ordered pairs all look like x comma y, then x comma y is the same thing as x comma x, because y is equal to x. So this line, y equals x, must have the property that all of its ordered pairs have the same number in both coordinates. Then it would make a picture, it would make a graph of a diagonal line perfectly at 45 degrees. This would be exactly 45 degrees. Why? Because it would have to go through all those points, like 1 comma 1 and 2 comma 2 and -5 comma -5. It would necessarily go through all of the ordered pairs that have the same value in the x position and in the y position. This line has a special name. It's called the diagonal. It's also called the identity function. I bet you can guess why it has both those names. It's the diagonal because it goes perfectly diagonal across the plane, and it's the identity function because whatever you gave it for x, it makes the other coordinate become identical. Both sides of the independent, no, x is identical to y. That's why it's identity. All right. This is an important function. Look at how it goes through the origin. It goes through the origin. It must go through the origin because the point 0, 0 is one of those type of points that has the x coordinate and the y coordinate as the same number. That's the origin right there. So this is an important line. If you understand this equation and how all those points are right on this line, only then can we move on. Like if we don't get this, we won't get the rest. So if there's any trouble, tell me now. We can always come back. You know, it's not like we can't come back, but
So that was called the diagonal identity function?
It's two names. So you can either call it, so this line is so unique and special that it's got these nicknames. The diagonal is one of them. And another nickname is the identity function. Now I'm going to add one layer of difficulty, and I'm going to keep adding more layers until we're all the way there. This is a linear function. Or a linear equation. It looks, for the most part, just like the previous one. In fact, that right there is the previous one. And now we're going to look at this one. The previous one just said that the x-coordinate and the y-coordinate were the same number. And this one says that the y-coordinate is the same as the x-coordinate, but it's plus 1. It's 1 unit more. The y-coordinate is 1 unit more than the x-coordinate. I can make a table even of maybe some candidates for such a line. It's very common to make a table like this. It winds up being just a collection of ordered pairs. Like if I was talking about the number, when x was 0, then the y-coordinate would have to be 0 plus 1. And if x was 1, this would have to be 1 plus 1. And if x was 2, this would have to be 2 plus 1. So for any x value, the y-coordinate is x plus 1. These correspond exactly to ordered pairs. Stop that. Go away. Cat's on the desk. So ultimately, we can say that an ordered pair that we would find on this line looks like this. They must look like that because that's what the equation told us the points would look like. Because the y-coordinate is defined to be x plus 1. We could make a drawing of this line, make a graph. Should 0, 2 be 1, 0? It should be 1, 2. The x-coordinate is 1 and the y-coordinate is 2. It was a typo on my part. Yeah, then you can just look right down at all the x coordinates that go 0, 1, 2, 3, blah, 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 out to x. And the strategy for getting the y coordinate was to just take the x coordinate and add 1. And that's how we always got the y coordinate. And it makes this picture where that's the ordered pair 0, 1, and there's 1, 2, and 2, 3. And if I were to overlay a picture of our previous example, the diagonal, look at how every point on the diagonal just moves up by 1. So this point was at 2, 2, and then it moves up by 1, and now it's at 2, 3. And this one was at 1, 1, and then it moves up by 1, and now it's at 1, 2. So we could take that diagonal and just scoot it up along the y-axis by 1 unit and get this new line. And that is exactly what our equation says. Our equation says, take the diagonal and scoot it up by 1 unit. There's nothing else going on. And then all of the ordered pairs would just look like this. All of the ordered pairs on the diagonal looked like x comma x. And if I'm just going to scoot everything up by 1, then all of the ordered pairs on this new line would be x comma x plus 1. Questions?
So on the original line, it's x comma x. Why is it not x comma y?
Because for that line, the equation was y equals x. Then the writing x comma x is identical to x comma y, because y is x. Y is x, is what it says. In the same spirit, this line has this rule for obtaining the y coordinates from the x coordinates. This rule says that we can determine what the y coordinates must be by taking the x coordinates and adding 1. So then you can write any ordered pair on that line as x comma x plus 1, because y is equal to x plus 1. Make sense?
A little bit. I'm just trying to understand the y equals x part. Like, I'm trying to figure out where exactly you got that from.
Sure. We got it from back here, right?
Oh, I got you. Okay.
We started with this basic, our first line, the diagonal, and we said this equation is going to describe a line, because now we have the Cartesian coordinate system where all of the ordered pairs look like the x coordinate and then the y coordinate. Well, if I then plop down an equation that says y equals to x, then there becomes no difference between an ordered pair x comma y and the ordered pair x comma x. They're the same thing, since y is equal to x. Now that's for this diagonal. When I change to this line, it's exactly like the diagonal, but has the +1. So then it says that your strategy for determining what the y value should be is to first take the x value and then add 1. So then you can get any ordered pair on this line as x comma x plus 1. Like, look at this one, 2 comma 3. That's exactly 2 comma 2 plus 1. And if you pick your favorite number, then we would know the corresponding y value that went with it.
I have a question.
Yeah.
When writing down the coordinates, which one should be started first, the x coordinate or the y coordinate, or the other way around?
It is always the x coordinate first.
Okay, thank you.
So hold on one second, my software crashed. So the naming convention, I mean, it very easily could have been decided that it was the other way, but this was done hundreds of years ago and we never changed it. It goes x comma y, the numbers on the x-axis and then the numbers on the y-axis. Okay. So, Rosalinda, that's why I can write what any ordered pair on this line would look like, because I can just pick any old random x value and it's determined for me what the y value must look like. The y value must look like that, because that's what y is. It says y is equal to that. Okay? So x comma x plus 1 is always a point on the line. In reality, that's all really a line is a collection of points. They form, it's not merely a collection of points. It is a collection of points that forms a line. It's straight. Here's another line. Right there is -5 on the y-axis. If I say that so this line must go through that point because that dot right there has the ordered pair 0, -5. It's 0 in the x direction, and it's -5 in the y direction. So it's the ordered pair 0, -5. And my line is right here. And we can talk about any point on this line that we would like, because all the points look like, here's my x value, and then my y value is x minus 5. You take how do I find the y value? You take the x value and subtract 5. That's what it says. That's what this rule says to do. How am I going to find y? I'm going to take x, I'm going to subtract 5, and that's y. So then maybe I'm curious about, I don't know, that number, 7. When x is 7, the ordered pair would have to be 7, 7 minus 5, which is 2. In the context of the diagonal, note that this line that we have is parallel to the diagonal. They're doing the same thing, except for if I had started with the diagonal and wanted to build this new line, I would take my diagonal, I would scoot every point on the diagonal down by 5 units. Remember that the diagonal went through 0, 0 because the x and the y coordinates had to be the same. And if I scoot it down 5 units, then it would go through 0, -5. Because I'm moving it downward. That's in the y direction. And I'm moving it down, so I'm taking away. Previously, right here, it would have been at 7, 7. But I scooted it down by 5 units. Now it's at 7, 7 minus 5. Then evidently, from the last couple of examples, it's kind of like, or it's precisely like, starting off with the diagonal, and then we scoot it. It just amends the rule from being do the same thing as what x is doing to now it's do the same thing as x, but take away 5. And then all the ordered pairs look like this. But hey, I could just go through here and change all these minus 5 to just say plus b. And if I did that, it was a direct replacement. I mean, instead of having the symbol minus 5, I said minus 5 is now this letter B. And everything's the same. The only thing that happened was this replacement. So then we're nearly there. This is y equals x plus b. Half the battle's done. If you can understand this, then half the battle's done. All we've done is take the diagonal, a line that we all understood, and just moved it up or down. And the symbol that we want to use to describe how far we moved it is B. B is how far we're going to scoot it up or down. And if B is positive, we're scooting it up. And if B is negative, we're scooting it down. And in this case, I said B was minus 5. So it went down by 5 units. Now we go back to the drawing board. Let's start off with our diagonal. And we're just going to doctor that diagonal a little bit until we get something different. So instead of looking at y equals x, let's look at y equals 2x. This is a linear equation. It has a graph that looks like this. X-axis, y-axis. This rule says that all of the points on this line have to look like x comma 2x. Here, let's make a table. So here's my table. Here's x values, y values. Let's go from minus 1 to 0, 1, 2, 3. Then the rule says that the y values should be twice what the x values were. But I claim that these are exactly ordered pairs. This table idea is nothing more than a list of ordered pairs. Like this one here is the ordered pair 3, 6. And ultimately, all this list is saying is that your ordered pairs look like x comma 2x. So it would have to go through the origin because 2 times 0 is 0. It would have to go through the point 1 comma 2. Because if I took that number 1 and just multiplied it by 2, you get 2. It goes through, if that's 8, then this ordered pair up here is 8 comma 2 times 8. 8 comma 16. So there's just going to be some kind of rule given to you via this equation, and it will dictate for you how to find it tells you the relationship between the x-coordinates and the y-coordinates. It tells you the relationship between the x-coordinates and the y-coordinates. And it literally says that the y-coordinates are always twice what the x-coordinates are. And that's it. This number 2 has the name of the slope. Is its name. We keep our definition of slope simple. It is rise over run. Starting from right here at the origin, if I ran all the way out here 8 units and I rose up 16 units, then you can see plain as day that with my rise being 16 and my run being 8, that my slope must just be 2. If this was just some random x-coordinate, and I was talking about this ordered pair, then I'd have my x-coordinate, and I know what my y-coordinate looks like. It has to look like 2x. So then, how far would I have to run? I would have to run x units, and my rise would be 2x units. And then the x's cancel, and I get a slope of 2. This number this number is called a coefficient that's being multiplied by this x. That coefficient is the slope when it's a linear equation. And it usually gets the symbol m. Okay, then. If I had this as my rule, it has a slope of m. It must go through the origin because all the points on this line have to look like x comma mx. And if it's gonna have an x value of 0, if I say out of the blue, let me take x to be 0, then the y value has got to be m times 0, which necessarily would be 0. So it must go through the origin. And just suppose it looked like this. Then if I had a run of 1, if I said that my run was 1, then my rise would have to be m, because m over 1 is m. So I could rise up here to m and be at another point on the line whose ordered pair is 1, comma, m times 1. Or if you picked 3, then you'd be at the point 3, comma, m times 3. It's just like the diagonal, but like modified by this quantity m. Just in the same way that this was nothing more than the diagonal, but had the 2. Instead of a 2, I've got an m. They're both numbers. M is a number. I just don't know which one. It's not changing. It's not a variable. But it's a number. It's just concealed from me which one it is. I don't need to know which one it is to do this work. If I dress this up all the way, and let's say that that value right there, well, yeah, that's fine. Let's say that that value right there is the value b. Then it would be just like the line in white, but it would be scooted up by the quantity b. This point would move up by b, and this point would move up by b, and this point would move up by b. And every point on the white line would become a point on the red line if only I would add b. Well, we're all the way there. This is called the slope-intercept form. It's called the slope-intercept form because you can witness what the slope of that line is, and you can see where it's going to cross the y-axis. It must cross the y-axis at b, because all of the points on such a line would look like x, comma, mx plus b. And if x were 0, then it's m times 0 plus b. And m times 0 is just 0. So it must go through the point 0, comma b. One example before we go to break. Y is equal to 3x plus 1. It's looking like this. No, that's too steep. It's looking like this. See that everything here makes sense to you. If my run is 1 and my rise is 3, starting from right here, I ran 1, I rose 3. Then my slope would have to be 3. And since it crosses the y-axis right here at the point 0, 1, that's exactly what this line describes. It talks about all of the ordered pairs that look like x, comma, 3x plus 1. So 3 times 0 plus 1 is just 1. It has to go through the point 0, 1. If x were 0, this part's gone, and it just says y is 1. And the slope has got to be 3, we're told. This says make it with a slope of 3. Well, okay. Slope is just rise over run, and that's what's happened right here. You can do it between any 2 points. I just did it with these two. It's the easiest to see. And you wind up here at the ordered pair 1, 4. It has to be 1, 4 because 3 times 1 plus 1 is 4. That's the y value whenever the x value is 1. All right, let's take 10 minutes. I'll set the timer. When I come back, we will see if there's any questions and dig into the rest of these homework problems. All right, I put a question on the attendance app, so check it out. And
Hello.
yeah,
Okay, I thought I was disconnected.
so the part of the homework over linear equations starts off with making a table. And here you can see they've given us a rule, and that rule is y equals x minus 1. Now I can tell you that in all likelihood this is going to go -2, -1, 0, 1, 2. -2, and once you put the y value, they're going to ask you about -1, and then they're going to ask you about 0, and then 1, and then 2. Now, according to our rule, we can always get the y value by taking the x value and subtracting 1. So this would be -2 minus 1. And this one is -1 minus 1, and 0 minus 1, and 1 minus 1, and 2 minus 1. Since our slope here was just 1, right? Technically, you have a 1 times x. The multiplicative identity says 1 times x is x. So that slope has to be 1 because 1 is the coefficient on the x. And that would be why these numbers just increment by 1 every time. Just like I incremented by 1 over here, these will also increment by 1. They're always just 1 unit less than x, and that's how you find your answer. So we would have -3 and then -2 and then -1 and then 0 and then 1. And then they want me to graph it. Okay. thought there was a... Oh, I know what I have to do. I just need to click on the graph. So since my table now exactly corresponds to a list of ordered pairs on this line, then all I need to do to graph it is if I click anywhere on the graph, it brings up the toolbar below it, which is just off of the screen. I'm going to change it so you can see it. So the little toolbar comes up down here at the bottom, and I need to pick the line tool. And then now I'm ready to select 2 points on this line. I will use the ones that are called the intercepts. The intercepts are the ones that have a 0 in one of the positions. So this one has a 0 in the X position and a -1 for Y. So I will point to that point and then click once. The other intercept is right below it. It's the ordered pair 1, 0. So I will point to that point. Click it. 2 points define a line. And that's it. Looking at our rule, y equals x minus 1, it says that it should be the diagonal, but scooted down 1 unit. And that's exactly what we have graphed. And you can see this line, see how it goes through the corners of all those squares. It's perfectly at a 45-degree angle with respect to the horizontal axis. That's something only a slope 1 line will do, and that's what the diagonal does. Complete the table for the equation x minus y equals -4. So they started us off with x minus y equals -4. Okay. There is nothing wrong at all here with solving it explicitly for one of the variables, or both of them. Right? I can say that the x value should always be looking like y minus 4. I just added y to both sides. So that way, if somebody gave me the y value, I could stick it right here, subtract away 4, and I would know what x value corresponded to it. Likewise, I could solve this equation for y. It would say y is equal to x plus 4. I just added 4 to both sides. It's all the same line. It's all the same relationship between x and y. All 3 of these writings. This one would be convenient for if somebody brought me a y value, like let's say 0. If somebody brings me a y value like 0, then it's super easy to say x equals to 0 minus 4. That means it goes through this point. Or if somebody brought me an x value, I would use the other one. If x were 0, then it says that x is 0 plus 4. That's 4. Then I have generated the intercepts. Each of these are called the intercepts. This one is the x-intercept. This one is the y-intercept. This one's the y-intercept because that's where it crosses the y-axis. This other one's the x-intercept because that's where it crosses the x-axis. Now, you didn't really need to make these other two equations to get this information. You could have just used the thing that you were given right from the outset. Because if I had said, let's just suppose that y was equal to 0, then if y was equal to 0, I wouldn't even be looking at that part. It would just say x is minus 4. Or you could say, conversely, let x be equal to 0. If x were equal to 0, then you wouldn't have that part. And it would say minus y is equal to minus 4. Well, that just means that y is 4. Then these two statements are exactly the same meaning as, that's what they mean. Y is 0, x is minus 4. That's this one. X is 0, y is 4. That's this one. And that's what they're going to be asking us for here. When x is 0, y is 4. And when y is 0, x is minus 4. And if x is 2, so here they've given me an x value. Since they've given me an x value, the convenient format to use is this one. Because I can just take that x value, plop it right there, and it would say 2 plus 4. So y would be 6. When x is 2, y is 6. When x is 1, y is 1 plus 4. Now they would like for me to graph it. I click anywhere on the graph, it brings up the toolbar at the bottom. You pick the line tool. Get in the habit of plotting your line using the intercepts. So I will click on the point 0, 4. That's this one. I will click on the point minus 4, 0. Minus 4, 0. That's our line. Look back at our equation here, the way we had it written in this format. That format right there, the slope-intercept form, tells you that this line is going to cross the y-axis at 4 and have a slope of 1. That slope of 1 being the same slope as the very first line we studied today, the diagonal. And look at how this line behaves like that. It goes perfectly at a 45-degree angle because look, it goes through the corners of all those boxes. And it crosses the y-axis right at 4. This is our line. Now they just want us to jump straight to it. Use the intercepts to graph the equation. And the equation they've given us is 4x plus 3y equals 12. You could sit here and explicitly solve it for x or y. It'd be a lot of work. You don't really have to. It's so easy to just say, let x be 0. If I am letting x be 0, then I am talking about the point 0, comma b. I would just be determining which number b really is. It would be the y-intercept. If x is 0, we're discussing the y-intercept. And if x is 0, then this term is just gone because it's 4 times 0. Evidently then, when x is 0, 3y is 12. If x is 0, then 3y is 12. So y would be equal to 12 over 3, which is 4. It goes through the point 0, comma 4. That's an intercept. It's the y-intercept. On the other hand, we can say let y be 0. If I'm talking about where y is 0, then that's where it crosses the x-axis. And if y is 0, then this term is gone. Because 3 times 0 is 0. And if y is 0, then it must be the case 4x is 12. And if 4x is 12, x must be 12 divided by 4, which is 3. So it would go through the point 3, comma 0. When I go to make my sketch, it's asking me explicitly to graph it via the intercepts. Don't graph it with any other 2 points or it will count it wrong. You need to plot these 2 points. So if that's 3 and this is 4, then guess what? It goes through those 2 points. This is the graph of the line. I can see explicitly what the slope of this line would be. Because to do my rise over run, I would have to go down 4 units. And I would have to go over 3 units. I can see that my slope is minus 4 over 3. I could write this equation, y is equal to minus 4 over 3x plus 4. If you sat there and solved this thing for y, this is what you would get. I didn't solve anything. I didn't do any algebra. All I did was say, well, this is one of the intercepts and this is the other intercept. I can easily see what the slope would be from there, and I know where it crosses. So it has to satisfy this format. Also, It's not asking me for anything like that here, but it will ask you for something like this soon. All right, so I'm going to graph this thing by the intercepts. I will click on the ordered pair 0, 4. I will click on the ordered pair 3, 0. That's all there was to that equation. Now on this one, they say that you'll find the x-intercept, the y-intercept, and then graph it. But it won't be a graph like the previous two questions. It'll just give you some pictures of graphs, and you will pick the correct one. Reason being is that this equation has an awkward slope. It's not an integer. So 11x plus 21y is a minus 33. If I let x be 0, then I'm going to be talking about the y-intercept. And if x is 0, then this term is gone. It would say 21y is equal to negative 33. In which case, y would just be a minus 33 over 21. But that fraction simplifies because a minus 33 is 3 times negative 11 over 3 times 7. And the 3's cancel, so we know now that it crosses the y-axis at minus 11 over 7. So our y-intercept would be 0, minus 11 over 7. That's our y-intercept. Our x-intercept is when we let y be 0. It flip-flops, right? If x is 0, it's the y-intercept. If y is 0, it's the x-intercept. If I let y be 0, then this term would be gone. And it just says 11x is a negative 33. I can divide both sides by 11, so then x would be a minus 33 over 11. Well, that's just negative 3. So it must go through the point negative 3, 0. Make a sketch. Plot those 2 points and connect them. And you can't go wrong when it comes to the third part of the question. I don't need to know exactly where negative 11 over 7 is. All that really matters here is that it's negative. It's a little bit bigger than 1, and it's negative. So that's about where it lives. And the other one is over here, negative 3, 0. It goes through those 2 points. That is the line. Okay, so now I can tell it my x-intercept. The x-intercept was where y was 0. So there's my x-intercept, and my y-intercept is where x is 0. So there is my y-intercept. And now they want me to choose the graph. But you know what? There is only one graph on here that's even oriented in the same direction. And that's option B. Look back at what our sketch was. Our sketch had the line going downhill. From the left to the right, always from the left to the right. It was going downhill. And option B is the only one behaving that way. That's the one. Four different versions of this question. You will see this question on the homework. You will see it on the quiz. You will see it on the midterm. You will see it on the final. And you will see it on the signature assignment. We will now study all four versions of this question. It has to do with the definition of slope. Slope is rise over run. And if I was talking to you about a horizontal line like this one, it's horizontal. Pick any 2 points. How much did it rise? How many units of rise are there between these 2 points? With the knowledge that this line is horizontal, how many units of rise? 0. The run can be anything that isn't 0. And as long as the denominator is not 0, the whole thing is 0. 0 over whatever number that's not 0 is just 0. Horizontal lines have 0 slope, have slope 0. Horizontal lines have slope 0. With our definition of slope as rise over run, still, never make it more complicated than that. If you know some goofy formula for calculating the slope, and you can use it without messing up, then sure, whatever. But I'm not going to talk about it here. And we don't need to. Yeah, no problem. Rise over run is what slope is. It is the definition of it. It is the definition. And any formula associated with this comes exactly from this definition. Okay, so horizontal lines have slope 0. Now, instead of a horizontal line, maybe now I'm talking about a vertical line, like this one. On a vertical line like this, the x-coordinates are always the same. The x-coordinate is always the same. So let's suppose, I don't know, that it went through the x-axis right there at 3. The equation for this line is x equals to 3. That equation says my x-coordinate is always 3. So this would be like the ordered pair 3, 4, and this would be the ordered pair 3, 6. And how much run are we getting between those 2 points? 0. There's no run. The run is 0. And it doesn't matter what the rise is, because this bunch of writing doesn't mean anything, at least not in math. It has no meaning. It is undefined. We can't define it because it's divided by 0. You can't divide by 0 because if you did, you'd immediately have a contradiction. Vertical lines have undefined slope. Vertical lines have undefined slope. I can see that this line was vertical immediately because the x-coordinates were the same. If the x-coordinates are the same, then it can't do any running. Over here, the y-coordinates were the same. You know, maybe that's crossing the y-axis right there at 3. Then this would have been a comma 3, and this would have been b comma 3, and the y-coordinates are the same. And that's what happens on horizontal lines. The y-coordinates are the same. Horizontal lines have 0 slope, vertical lines, undefined slope. It's just a matter of where's that zero. For a horizontal line, the zero's in the numerator. For a vertical line, the zero wound up in the denominator because there's no run, giving you an undefined slope. Okay, third case would be a line that goes like this. There's a point, there's a point, just picked them at random. Always going from the left to the right, start at the point that's on the left and do your rise. Here we're doing a negative rise because it's going down. So it would be some negative number. And if you're going from left to right, the run will always be positive. Your slope would be a negative number over a positive number, which would wind up being a negative number. This has a negative slope. It's going downhill. It's got to be a negative slope because starting from the point on the left, all the points to the right of it are underneath it. So you will have to have a negative rise. A run's always positive, so a negative over a positive is negative. Finally, our last case would be a line looking like this. It goes uphill. If I'm looking at this point and then this point, I would have to rise, I would have to run. This is positive, this is positive. So you'd have a positive over a positive. That's a positive number. This has positive slope. And those are the four cases. So for me, on my question, it was talking about an undefined slope. That's the vertical line, because the run is 0. Now it's asking me for a positive slope. That's the one that goes uphill. Now it's asking me about a negative slope. That's the one that goes downhill. It's asking me undefined again. But if it had said 0 slope, it would be this one. That's 0 slope. But it skipped that one for whatever reason. Now it's back to undefined, so I'll just leave it. We'll go to the next question. I'm given 2 points. They want me to tell what the slope is, and they want me to say if that line goes uphill or downhill. And like I said, if there's some formula that you know, whatever. But if you don't know what I'm talking about with that, don't bother. It isn't worth it. I don't even hardly do it like that. Draw a picture. Draw a picture. If you draw a picture, you virtually cannot mess it up unless you just plot the points wrong. It doesn't even have to be a good picture, just a sketch. Plot my points. This point here, -6, -2, is right there. The y value is -2, the x value is -6. That's the ordered pair -6, -2. The other ordered pair, -2, 30, is this one. Because the x value is -2 and the y value is 30, that's the ordered pair -2, 30. I can already see what the answer to the last part of the question would be. This line goes uphill. It rises as we move from left to right. It rises. It goes uphill. Same difference. How can I calculate what the slope would be? Easy. I can see very plainly what my run would be. My run just has to go from -6 to -2. That's 4 units. Now, when I rise, I'll have to do it from -2 all the way up to 30. So first I'll go 2 units, and then I'll go 30 more units for a rise of 32. And that simplifies just to be 8. The slope is 8. The slope is 8, and it rises from left to right. Or maybe you would like to do the rise first and stay away from all this other writing I have down here. That's fine. Starting from the point on the left, I would have to rise 2 units, and then I'd have to rise another 30 units. That's 32 units. And then when I run, it's just like from -6 over to 2. You could take this little arrow here and kind of scoot it down, and it's the same as any of these distances. From, on the x-axis, from -6 over to -2, is the same distance as from right there to right there. So my run would just be 4. And then my slope is 32 over 4, which is 8. So with a slope of 8, don't type m equals 8, just type 8. The slope is 8. And having a slope of 8, it's positive, so it rises. Then they ask you a similar question. But we could answer this question without even lifting our pencil. Look at the points that you were given. The points that you were given. Those 2 points have the same y-coordinate. Imagine a line in your head, oriented in any way you would like, and then rotate that line in your mind so that this line has the same y-coordinates. For any 2 points on the line, it would have the same y-coordinates. What's the slope? Majesty, go ahead and make a sketch. Plot these 2 points. If a line has the same y-coordinates all the time, it can't rise. You can see from these 2 points, look, the x-coordinates are different, so it's got some kind of run going on. But the rise is always the same. It's not merely the same, it's 0. It's nothing. It can't rise. The rise is 0. The rise is 0 and the run is something else. So what's the slope of this line?
Zero.
It's 0. The slope of this line is 0. It's a horizontal line. In fact, since the y value that it goes through is 0, this line is the x-axis. And then you get this drop-down menu, and you would just say that a line of slope 0 is horizontal. It always has to go through. So on this line, the x-coordinate can be anything you'd like, and the y-coordinate must be 0. In fact, it would have equation. The equation of this line is y equals 0. Because that equation, y equals 0, just says y is always 0. All right, now they want us to, from this equation, put it into slope-intercept form, write down the slope, write down the y-intercept, and make a graph. And what they have given us is minus x plus y equals minus 6. To say slope-intercept form, is identical with saying solve it for y. Because after all, that slope-intercept form is y equals mx plus b, and that's exactly what that thing is it is solved for y. So all I need to do is add x to both sides. Y equals x minus 6. Multiplicative identity says that x equals 1 times x. The only reason I am making that writing right here is just to make sure that you know. There is a coefficient there in front of that x, and that coefficient is 1. So our slope is 1. Our y-intercept is the ordered pair 0, minus 6. And the slope-intercept form, I'm going to type in this right here, because it is exactly the form y equals mx plus b. If you typed in this, it might take it, but it also might not be smart enough to know about, the number 1. It probably wouldn't like it, because I could also just say 1 times 1 times 1 times 1 times 1 x, and it's technically true, but I doubt that it would know what you mean. Nobody writes the 1. Okay, so we would say y equals x minus 6. The slope is 1. Don't say m equals 1. It'll count it wrong. The slope is just a number. M equals 1 is an equation. The slope is not an equation. The slope is a number. So don't type an equation. The y-intercept is a point. It's not just a number. It's a point on the plane. It's the point that's got to have 0 as its x-coordinate. And here, it's going to have minus 6 for the y-coordinate. That's where it crosses the y-axis. Slope of 1 means it behaves like the diagonal. This is the diagonal, but it's scooted down by 6 units. That's all this is. So since I know it goes through 0, comma, minus 6, then that's one of the points. My slope is 1. Now it would be tedious to go up 1 and over 1, but you can. Look, I'm doing it right now. I'm going up 1 and over 1. I could click that right there, and then that would be it. If I wanted to graph it by the intercepts, I could click this point. Look how it goes through all the corners of all the boxes. That's a slope 1 line. All right. 7x plus 6y equals to 42. Same objective. Write it in slope-intercept form. Tell me the slope. Tell me the y-intercept. Okay. You could solve this for y. You could subtract over the 7x. You could divide both sides by 6. It would be solved for y. Or if I say to let x be 0, and find the intercepts, I can do all that same work with no algebra. Just facts about lines. If x is 0, then 6y is 42. So y is 7. It goes through the point 0, comma 7. On the other hand, if y is 0, then 7x is 42. So x equals 6. It goes through the point 6, comma 0. I now have both the intercepts. I can make a graph of this. There it is. Whoop. There it is. Now, tell me, can't you look at this graph? Starting with the point on the left, going to the point on the right. How much is my rise? How much is my run? It's very easy to read it off when you're dealing with the intercepts. My rise is minus 7, my run is 6. I had to go down 7 units. I had to go over 6 units. My slope is minus 7 over 6. The place where it crosses the y-axis is 7. So my slope-intercept form has got to be minus 7 over 6x plus 7. That's my slope-intercept form. This is my slope, and this is my y-intercept. And I'm done with the problem. You can type all that in, and you get it right. The last 3 problems are a different style. They're more elaborate. So 13 and 14 are like this, and then 15 is the top level elaboration. Here they've given you the slope. They've said, look, the slope of this line is -5. And then they said, it goes through the point 5, 6. And they want two versions of the line. They want it in slope-intercept form, and then they want it in standard form. We'll talk about standard form in a moment. But we know slope-intercept form, it's the form y = mx plus b. I've got m, so I can at least say that y is equal to -5x plus b. I know that my line has got to look like this. Gee whiz, I just wish I knew what the b was. Well, you know a point. This point is an x, y. This point, since it's on the line, has to satisfy that x, it has to satisfy the rule that it goes through the point x, minus 5x plus b. Because this is what y is. So we can just take that number 5 for x and substitute it in. We can take that number 6 for y and plug it in. And this equation must hold because it goes through that point. Well, look at what you're left with. You're left with an equation whose only unknown is b. So you solve it for b. This says 6 is the number -25 plus b. So then evidently 6 plus 25, that's what b is. B must be 31. Then ultimately, my slope-intercept form is y equals -5x plus 31. That's my slope-intercept form. Now, if you want this other form called standard form, I don't really know what's standard about it. It is when it has this shape, ax plus by equals c, where a is not negative, and where a, b, and c aren't fractions. Or excuse me, yeah, a, b, and c are not fractions. So what you need is for the x term and the y term to be on the same side. You need to make sure that the coefficient on the x is not a negative number and that there's no fractions. So you can build it out of your slope-intercept form, starting with the idea that y is -5x plus 31. Just add 5x to both sides. Then 5x plus y, that's 31. There's my standard form. There is a question in the attendance app that I just submitted. Carly, what do you want me to explain again? How to get or what the standard form is? Okay. So standard form is where it looks like this. Notice what it's solved for. It's solved for a number. It's solved for a number. You've got the x and the y term on the same side of equals. And A, B, and C are not, just pick one. Pick a yes or pick a no. I forgot about that. The A, B, and C are not fractions. Doesn't this then satisfy those requirements? It's got the x and the y on the same side. A is 5, B is 1, and C is 31. None of those are fractions. And 5 is not negative, so this must be the standard form then. They've got one more like that for us. They say the slope is minus 11 over 16, and it goes through the point minus 8 comma 16. So it's got to start looking like y equal mx plus b. M is minus 11 over 16, so this says y equals mx plus b. And the minus 8 comma 16, that's an x comma y, so I could say that 16 has got to equal minus 11 over 16 times negative 8 plus b. Because there's my x and there's my y. And then now you have an equation that only has b, so you can solve it explicitly. We would have that 16 is 11 over 2 plus b. And I would subtract the 11 over 2 on both sides. 16 minus 11 over 2 is b. 16 is really the number 32 over 2. You can see that because you can multiply by 1 in the form of 2 over 2. So here is 16 right there, 32 over 2. I got 32 of those things minus 11 of those things where those things are over 2, over 2s, whatever that means. I mean, 32 apples minus 11 apples, 32 halves minus 11 halves. It's all the same thing, same idea. 32 minus 11 is 21. So this is 21 over 2. You get 21 over 2. That b is 21 over 2. So now I can write my slope-intercept form. It is y equals minus 11 over 16x plus 21 over 2. There's my slope-intercept form. Now I want to put it into standard form. So it needs to look like an ax plus by equals c. What's the second to last step, Sarah? Second to last step was technically here, but surely you're not talking about that. Do you mean this? So, assuming that everybody has it up to here, how did this wind up being 11 over 2? Well, it says minus 11 over 16 times minus 8. This is identical to minus 11 times minus 8 over 16. The two negatives, it's a multiplication of two negatives, well, that's positive. So it's a positive number. It's 11 times, and surely you can talk to me about 8 divided by 16, because 16 is just 2 times 8. These 8s cancel. This is 11 times 1/2. It's 11 over 2. So that's how we would get the 11 over 2 right here. I need to solve it for b, so I subtract that number to the other side. It's 16 minus 11 over 2. This is what b is. But I can't make sense of it. It's like saying 5 apples minus 3 oranges. I don't know what that means. But if they were both apples, I could do it. I would know exactly what it means. Make it say that with the power of multiplying by 1. There, I've multiplied the 16 by the number 1. So it's still 16. This is still 16. But it also says 32 over 2. 32 over 2 is 16. 32 over 2 minus 11 over 2. It might as well say 32 apples minus 11 apples. It's no different at all. 32 minus 11 is 21. 21 apples. And that's B. So we wind up with minus 11 over 16x plus 21 over 2. This is our slope-intercept. We now want to put it in the form ax plus by equals c, where a is bigger than or equal to 0, and a, b, and c are not fractions. So you move this term to the other side using your additive inverses. You would have 11 over 16x plus y equals to 21 over 2. Look around at your denominators. Choose the biggest one. The biggest denominator is 16. Multiply everything by 16. 16 times this, 16 times this, and 16 times this. It won't have any more fractions once you do that, because 16 times this is necessarily 11x. The 16s will cancel. I multiply this side by 16. I multiply this side by 16. You would get 11x plus 16y equals to 21 times 16 over 2. 16 over 2 is just 8. It says 21 times 8. And 21 times 8 is 168. It's now in standard form. All right, 9:30. We didn't get to the very last question, but the very last question is just 1 iota more difficult, really not even. They give you 2 points, and they want the standard form. So you would have to find the slope first. You find the slope. Then you can easily write down the slope-intercept form and then just convert it to standard form, and you're done. All right, I will post this video. And
what about the
well, kind of ran short of time. So if anyone wants to stick around and talk discussion board, we can. The instructions on the discussion board are astoundingly clear for this week, but it is just about writing down your own linear equation. And what they want from you is for you to pick some activity. Maybe, so I'll pick the activity of tennis. My activity is tennis. And I will say, yeah, go ahead and check out. So, and then I will say, for my tennis activity, and I burn 400, I really get after it, and I burn 400 calories in one session. This is a rate. Calories per session, miles per hour. It's a rate. Rates are slopes, nothing more. The slope of a line, the rate of something, a rate is a slope. So then from this rate of 400 calories per session, I could write down a linear model that describes how many calories I could burn given some number of sessions. I do 2 sessions, I'll burn 800 calories. Okay. But they want you to go a little further. And they want you to say, well, tell me how much calories intake you will have. And then we can let this rate be negative, since it would decrease like your caloric balance in your body. Then this negative symbol here would quite literally mean to burn. I burn 400 calories per one session. And if you don't make this number down here be 1, then you are making it more difficult than is needed. So don't. The number in the bottom can just be 1 each. 400 calories each session. Don't get fancy and say it's something like, don't say that you're going to jog 2 miles and you burn whatever number of calories in 2 miles. Just say that it's for 1 workout. Okay. And maybe I'm on a 2,000 calorie diet. Then the equation 2,000 minus 400x, this equation would model a 2,000 calorie diet and a physical activity of playing tennis. Okay, then they ask you two questions. Or excuse me, they ask you to write two questions. You write these two questions, and then your peers answer them. The first question, I think, is, I think the first question I would write is just where like X is a number. How many calories? So how many calories do I have left to burn? How many calories are left in my calorie bank account? How many calories are left to burn after 2 sessions? You don't answer it, your peers answer it, but the answer is obvious. It's 2,000 minus 400 times 2, 1,200. There would be 1,200 calories left to burn. The second question, how many sessions would it take to burn all the calories? That's just where y is 0. How many sessions to burn all the calories? That's just where y is 0. It'd be 5 sessions. I'd have to go out and play tennis 5 times. And that's the discussion board. Pick an activity. Pick a number of calories you eat per day. Assign a calorie burn for that activity. Write the model, write the questions. You can take exactly what I have here and just change it. Maybe you eat 1,800 calories. Maybe you burned 300. Then it would say y equals 1,800 minus 300, x. That's it. All right, we're good?
Yes.
All right. I'm always available on Remind. So if you have any questions, just let me know. All right. I'll post this recording and I'll see y'all next week, I guess.
I just have a quick question.
What's up?
So like the 2 questions that you created, we don't have to like post our answers to them and then create like another 2, it's just 2 questions and then that's it.
That's it. Don't answer them.
Okay,
that's what people are supposed
okay.
to do in the response.
Okay, so we just have to come up with
Yeah.
2 questions and then like our peers have to answer them.
Yeah. And then for your 2 responses, you're going to answer the other people's questions.
Right. Okay. Okay. Thank you.
Yeah, for sure. Anything else? It is not due tomorrow. It is due 3 days after we meet.
Yes.
And to say due is even too harsh of a word. That's just when it would be terrific if you had your initial post turned in. So here we are, and then have your initial post here. This is where it's ultimately due. You've got to have it all in by Monday night, or you'll lose attendance points. Okay? All right, I'll see y'all later. Bye.